Hey everyone, today we are going to work on the practice factoring test. So we're going to go through some examples of factoring. Now with this first one, it does tell us to factor completely, and you should always factor completely as much as you can. And the very first thing you should always do is check for a greatest common factor. My numbers here are 2, then I really have a negative 1 x squared, and a negative 10 and a positive 5. There's no number that all those can be divided by, so there's no greatest common factor. So instead, we're going to look at factoring by grouping. So factoring by grouping, I'm going to go ahead and draw my line down the middle, and I'm going to use my upside down birthday cake method to help factor each half of this problem. So I'm going to start with my 2x to the third minus 1x squared. And with that, there's no numbers that they have in common. The only number you could divide both of them by is just 1. But they do have some variables in common. And when you look at the variables, you have to look at the lowest exponent. So our lowest exponent of x is 2. So we're going to take out x to the second power. Now, this x, this 2x to the third, that says we have 3 x's. X to the third means x times x times x. So if we take 2 of the x's out, we're left with just, whoops, let me go back to my black pen. We're just left with 2x. And if I take x squared away from the negative 1x squared, I'm just left with negative 1 here. Now I'm left with 2x minus 1, and there's nothing else that these have in common. So we are done with this side of the problem. Now this x squared is our greatest common factor. We're going to take that out. And then the parentheses come from our leftovers, what couldn't be factored. We're going to have this 2x minus 1. Then we're going to do the same thing for the right half of the problem. So I'm going to take my negative 10x plus 5. And again, I'm going to start with my upside down birthday cake. Now, 10 and 5 can both be divided by 5. So negative 10x divided by 5 is negative 2x. 5 divided by 5 is positive 1. And then negative 2x and 1 can't be simplified anymore. We are done with that. So our greatest common factor here is positive 5. So I'm going to put plus 5. And then our parentheses come from this negative 2x plus 1. Now, in order for a grouping problem to work, you have to have the exact same thing in each set of parentheses, which we do not. However, the only thing that's different is our signs. We have a positive 2x, a negative 2x, a negative 1, a positive 1. So we can kind of force this one to work. So instead of saying that they have a positive 5 in common, we can take out a negative 5. And what that's going to do is that's going to switch each of the signs inside the parentheses as well. And then what we had on the left side of the problem is not going to change. Now we have the exact same thing in each side of the problem. So we're going to take our greatest common factors that we had pulled out, and those are going to go in one of our sets of parentheses for the answer. And then in the other, we're going to have this 2x minus 1. And that's going to be our answer for this problem. We have x squared minus 5 and 2x minus 1. Now, we should always check our answers, and we won't necessarily do that for every problem throughout the review just because of time, but we will go over a couple examples like that. So we can use our area model, use our boxes, or we could use our FOIL method to multiply these back together and see if it equals our original problem. So here I have x squared times 2x, which is going to give me 3x squared. Sorry, 2x squared, because this is 1 times 2, which is 2. Then I have 2 times negative 5, which is negative 10x. 1 times negative 1 is negative 1x squared. And negative 5 times negative 1 gives me positive 5. And there's no like terms here that I can combine. So, oops, I forgot my exponent here because I was so busy fixing my coefficient. So we don't have anything we can combine. When we write our answer, we want to write it in standard form, which is highest to lowest exponent. So we're going to start with this 2x to the third, which is our highest exponent. Then we're going to go with the negative 1x squared, then the minus 10x, and the positive 5. And the way we know our answer is right is because our checked answer is the same as our original problem. So that one is done correctly. Now, number 2. If I look at this, Okay, when we have a binomial, we can check to see if it is a difference of squares. 16 is a perfect square, y squared is a perfect square, and so is 64. But, again, with every factoring problem, we always need to check for a greatest common factor first. And that's going to be really important because if you don't do that, you're going to end up missing parts of the answer. Now, 16 and 64 are both even, so I can divide both of those by 2. When I take out a 2, I'm left with 8y squared minus 32. And you may have seen a different common factor instead of 2 to begin with, and that's fine as long as you end up with the same thing at the end. Now, 8y squared and 32, I can divide both of those by 8, so I'm going to take that out. That leaves me with y squared minus 4. Now, there's no more common factors there. So let's look. Our greatest common factor comes from our numbers on the outside, this 2 times 8, which gives us 16. So our greatest common factor is 16. We're going to take that out. Then what's left is this y squared minus 4. Now, I don't see an answer like that. I do need to be careful because b looks pretty similar, but the squared's in a different place. So I need to check to see if what is in parentheses can be factored anymore. So here, y squared is a perfect square, so is 4. It is also a binomial, and it's subtraction. That means it follows the rules for our difference of squares problems. So when we have those kind of problems, we need to look at taking the square root of our first term. So a square root of y squared is just y. Taking the square root of our second term, the square root of 4 is 2. And then our signs are always one positive, one negative. Now, I can't forget that greatest common factor I took out at the beginning. That's going to have to stay out there at the end. So this one appears to match answer choice C. But let's go back and check. So ones like this are a little bit weird to go back and check because there are 3 parts being multiplied. But if we just start with our 2 sets of parentheses, we can use our area model here to multiply, and then we'll multiply the 16 in at the end. So y times y gives me y squared. Y times 2 gives me 2y. Y times negative 2 gives me negative 2y. And 2 times negative 2 gives me negative 4. Now, I do have some like terms. I have 2y and negative 2y. But those add up to 0, so I'm going to mark those out. That leaves me here, which is y squared minus 4. And now I can't forget about this greatest common factor, the 16. If I go ahead and distribute this back in, then that's going to give me 16y squared minus 64, which was our original problem. So again, always try and go back and check your work. That can be the difference between getting something right or wrong. All right, moving on to problem 3. It tells us to factor m squared minus 14m plus 49. So when we look at this, first of all, our leading coefficient's 1. So we know that there's not going to be a GCF. So that just means we're going to draw our x. We need 2 numbers that multiply to give us that 49, and that add to give us our middle term, which is that negative 14. So you can start by writing out some of your factors. Now, since they multiply to give you a positive and add to give you a negative, we know that they're both going to be negative. We can't have one negative, one positive, because those would multiply to give you a negative as well. So 49 is negative 1 times negative 49. That gives us positive 49, but that does not add up to negative 14. 49 is not even, so 2 does not go in. And our trick for knowing if it's divisible by 3 is if we add up the digits, 4 plus 9 gives us 13. That's not a number divisible by 3, so that won't work. 4 won't work because it's not even. 5 won't work because it doesn't end in a 0 or 5. And you have to keep going like that. Our next ones that work are negative 7 and negative 7. So negative 7 times negative 7 is positive 49. Negative 7 plus negative 7 does give us negative 14. So it is negative 7 and negative 7. So our answer here is m minus 7 and m minus 7. However, you can also write that answer just as m minus 7 squared. Because when you have something squared, that just means you're multiplying it by itself. Now number 4, this says 25a squared minus 4. Let me rewrite that down here so we have a little room. 25a squared minus 4. Now there's no GCF here because 4 is just 1 times 4 and 2 times 2. And neither one of those numbers will go into 25. So we need to go ahead and look at other options, not a GCF. So we need to check it's a binomial, it's subtraction. 25 and a squared are both perfect squares, and so is 4. So this, excuse me, this is a difference of squares problem. So we're going to take the square root of each of our terms. Now, the square root of our 25a squared, square root of 25 is 5. Square root of a squared is a. That goes at the beginning of each sub parentheses. Square root of 4 is 2. That goes at the end. And then 1 is a plus, 1 is a minus. Now, if I look at A, they are both minus, so that's not going to be my answer. B, they're both plus, and then C has totally different numbers here. So the only one that matches here is answer choice C. And it's okay that they have the minus one written first and then the plus one written second. You can change the order of multiplication. That's our commutative property of multiplication. 5 times 4 is the same as 4 times 5. It doesn't matter the order you multiply. So those are the same answer there. All right, number 5. So this one, actually, the instructions are wrong on it. So let's go ahead and fix this. This just should say factor out the GCF. Because the correct answer for factoring completely technically isn't on there. We can go look and see what that is, but it's not one of our answer choices. So let's start by finding our greatest common factor. So this says 5x squared plus 15x squared plus 10x. So we're going to use our upside down birthday cake method. And I see 5, 15, and 10. All those numbers are divisible by 5, so I'm going to take that out. 5 divided by 5 just gives me 1. 15 divided by 5 gives me 3. And 10 divided by 5 gives me 2. Now, I still see that they have a variable in common. All of these have an x. Now, I go with my lowest exponent. Remember, if it doesn't have an exponent there is 1. So my lowest exponent is just x to the first, or x. So when I take 1x away from the x to the third, I have x to the second. You take x away from x squared, and that just leaves me x. And then there's not going to be an x at the end. So here, our greatest common factor is 5x. So that's what we pull out. And then our leftovers here, or this bottom part of our cake, we have x squared plus 3x plus 2. So based on those instructions, our matching answer would be answer choice B. However, I'll show you why we need to be careful and read the instructions. Right here in parentheses, this could be factored more. There's no greatest common factor. Our a value is 1, so we're going to draw our x. I need two numbers here that multiply give me 2, and add to give me 3. And those are going to be 2 and 1. 2 times 1 is 2. 2 plus 1 is 3. So that allows me to break it down into x plus 2 and x plus 1 with that 5x still outside. This is completely factored. But now that we had fixed the instructions, and that will be fixed on yours, that should just factor out the GCF, which gave us two different answers. But most of the time you will be factoring as far as you can go. All right, number 6 here. It says find one of the factors. This is a great way of asking a question to see if you really know how to factor. A lot of the others you can work backward and just multiply to, although it'll be a lot of work, but multiply to see which of the answers matches the problem. This one, because it's only asking you to find one factor, there's no real guess and check here. So with this problem, our a value is 1. So that tells us we're going to draw our x. I need two numbers that multiply give me 81 and add to give me this negative 18 here. So if we could go through and make a list. You could also use your calculator to do that, and we'll look at that. So on your calculator, you'd press y equals, And then you're going to type in the number you want to multiply that 81 divided by x. And then we're going to go second and graph. And that'll take us into our table. Now let me scroll back to where it's closer to 0. Actually, we'll go the easy way. Okay, so I need, if I'm looking at this, since they multiply give me a positive, but add to give me a negative, they're both going to be negative. So I'm looking for two numbers side by side that add to give me negative 18. So I'm going to scroll into the negatives here. Negative 1 plus negative 81, nope, that gives me negative 82. We're going to skip all decimals. Negative 3 plus negative 27 gives me negative 30, so that's not going to work. Skip the decimals. Lots of decimals. Negative 9 and negative 9, hey, negative 9 times negative 9 gives me 81, and negative 9 plus negative 9 gives me negative 18. So let's go back here, and we know we have negative 9 and negative 9. So when we write our answer, we're going to have x minus 9 and x minus 9. Now this did just say find one of the factors, so notice they're both the same, so that makes things a little easier. And so it's just asking for one of your sets of parentheses. That's all it wants to know when it wants you to find one of your factors. The only one that matches here is answer choice A. That's your x minus 9. All right. So number 7, this says to factor completely. Now this is a binomial. It's subtraction. 36 is a perfect square. 27 is not. So that tells me instead of being able to do our difference of squares, we need to look to see if they have a greatest common factor. All right. So in this problem, 36 and 27, I can divide both those by 3. 36 divided by 3, well, 3 divided by 3 is 1, 6 divided by 3 is 2, so that's 12k to 6. 27 divided by 3 is 9. Now, 12 and 9, they can also both be divided by 3. 12 divided by 3 gives me 4. And 9 divided by 3 gives me 3. Now, 4 and 3, we can't divide those both by anything, so now we're going to start looking at our variables. I have k to the 6th and k to the 3rd. So I need to look at my lowest exponent there, which is k to the 3rd. And I'm going to take that out. So I had 6 k's all multiplied together, and I took out 3 of them, so that left me with 3. I had 3 k's here, I took them all out, and that just left me with a minus 3. So when I look at my GCF, my greatest common factor, I have to take all these numbers that we pulled out, the 3, and the k to the 3rd, and I multiply these back together. And that's going to give me 9k to the 3rd. That is our greatest common factor. Now, our leftovers that go in the parentheses are from this row right here. 4k to the 3rd minus 3. And if I look at this, I do want to check to make sure it's not a difference of squares. 4 is a perfect square. 3 is not. So therefore, we can't factor this anymore. And that matches answer choice D. All right, number 8 here. We got some big numbers going on here. So it tells us to factor 36h squared minus 30h minus 25. 36, 30, and 25, they don't have a greatest common factor because 25 can only be divided by, other than 1 itself, 5 and 5. And 36 cannot be divided by 5. So we're going to take this problem, and since our a value, our leading coefficient, is greater than 1, we're going to go through slide and divide. So our first step is to slide. That means we're going to take this leading coefficient and multiply it by the n. So that gives me h squared minus 30h, and 36 times 25 is 900. That's first step, slide. Our second step is factor. So we're going to take our trinomial, and we need to find two numbers that multiply to give us 900 and add to give us negative 30. All right, So this is a big one. I'm going to go back to my calculator for this one. So I pressed y equals, and I need two numbers that multiply give me 900. So I'm going to do 900 divided by x. And then second graph to go into my table. Now again here, I'm trying to find two numbers that multiply give me multiply give me 900, add to give me negative 30. Since they add to give me a negative, they're both going to have to be negative. So let's start here. Negative 1 and negative 900, those do not add to give us negative 30. Even negative 6 and negative 150, we're still getting negative 156. These numbers are huge compared to negative 30, sorry. So we're getting a little closer. Negative 10, negative 90, add to negative 100. Remember, skip all your decimals. Negative 50 and negative 60, that adds to negative 75. Just keeping going. Negative 30 and negative 30, that adds to give us negative 60. Once you start seeing the same number there, then we're going to start to see some repeat. We just saw this negative 25 and negative 36. Now we're going to see the same thing in a different order, negative 36, negative 25. So there were no two numbers side by side that added up to give us negative 30. If you cannot find any, then we would call this prime. Whoops. That means that it cannot be factored, which is answer choice D. So with that one, we are done. You're not going to typically run across a lot of prime problems, so you do need to be careful and avoid just giving up so easily and just assuming they're all prime. All right, number 9. When 9x squared minus 25y squared is factored completely, one of the factors will be what? So it just wants to know what one of the sets of parentheses is. Now, 9x squared minus 25y squared. Okay, we first always check for a greatest common factor. 9 can be divided by 3 and 3. 25 cannot be divided by 3. So there's nothing else we can do there. Okay, no GCF. So what we instead need to look at, this is a binomial, two terms. It's subtraction. 9's a perfect square, so is x squared. 25 is a perfect square, so is y squared. This is our difference of square problems. So remember, in all those problems, one is a plus, one is a minus. We're going to take the square root of the first term. So square root of 9 is 3. Square root of x squared is x. Then we're going to do the same for a second one. The square root of 25 is 5. And the square root of y squared is just y. Remember, a square root is just what multiplied by itself gives you that number. So it just wants to know which one of these is a set of parentheses there. And if I look at this one, that matches answer choice B. All right, now number 10. This tells us to factor. 3, 13, and 10 do not have any greatest common factor. So we're going to look at this. And since our a value is greater than 1, we're going to slide and divide here. So our first step is to slide, meaning we take this number in front and we're multiplying it by the last number. So we get x squared minus 13x minus 30. That's step 1, slide. And remember, our little saying to help us remember this was Swedish fish don't really swim. That can help you remember those steps because our next step is factor. So when it says factor, we need to draw our x. We're looking for two numbers that multiply and give us that negative 30 and add to give us negative 13. Now, if one is positive if they multiply, give us a negative, that means one is positive, one is negative. So we could list out our factors here if we didn't have a calculator. So we could do negative 1 times 30. That multiplies to give us negative 30, but that does not add to give us negative 13. 1 and negative 30, same thing. Negative 2 times 15 gives us negative 30. 2 times negative 15 does as well. Negative 3 times 10. 3 and 10 make 13. But we need to be really careful with that. Because, again, one's negative, one's positive. So 3 plus negative 10 really gives me negative 7. So since they add up to give us a negative, that means the bigger number is going to be negative. And we're looking right here at this 2 and negative 15. 2 times negative 15 is negative 30. 2 plus negative 15 is going to give us negative 13. So again, be really careful on problems like that. All right, so we factored in parentheses, we would have our x plus 2 and our x minus 15. So slide factor. Now we're going to divide. Now when we divide, we always divide by the number we slid at the beginning, that leading coefficient. So we're dividing here by 3. Our next step is to reduce. So that means we're going to simplify each fraction. Now over here, 2/3 cannot be simplified, so we're just going to write it. And then 15 over 3 can be simplified. 15 divided by 3 gives me 5. All right, and our last step is swing. What swing means is we're going to take any denominator we have and swing that number to the front. So instead of x plus 2/3, we're going to have 3x plus 2, and then x minus 5. That stays exactly the same. So this is our answer here. And if we compare, this is going to match answer choice B. So slide, factor, divide, reduce, and swing. And remember, all these can be checked by using either FOIL or the area model, which is your boxes. And if you want that good grade on the test and you have plenty of time, I would highly suggest putting them back in the boxes and checking. All right, I'll be back with the second part in a bit.